Hello, students. This is Mr. Selby here. I just thought I would take you through a little bit of kind of like a little bit of a quiz here, just to kind of feel like kind of a little bit to test your knowledge here on chapter 2, lesson 7. So this is 2.7. So this is actually a third video on this unit, on this section of this unit. All right. So hopefully you can kind of go through these at the same time as I am, kind of figure out how you're feeling on this. Okay. So the reason I'm going over this right now is to kind of go through some questions you may have. These questions may look familiar on the upcoming quiz. I'm not gonna name anything, but they're probably gonna be on the quiz. So yeah, I thought I would go over some of these. And I know last unit we went over, or last video, I kind of explained that this is important because it helped you formulate any kind of argument. Okay, not just argument, but it allows you to pinpoint reasoning, and that's kind of the whole point of proofs. Okay, it's pointing out something and explaining why it is, and that is proof. You're proving something, and proving things, as I've said in the past, is really important in any time you want to justify yourself. Okay, you want to use a proof. All right, and now I'm sure we're just using it for geometry right now, but you should be able to use reasons and use proof in everyday stuff. All right. And if you do have a direct question on this, you're like, Mr. Selby, I have no idea what you're talking about when you say use this in real life. Talk to me about it. Okay. Come to office hours. Okay. Let's work through it a little bit. Okay. So the statement, if segment AB is congruent to segment CD, then segment CD is congruent to segment AB, demonstrates which property of congruence. All right. So identity property, I'm not really 100% sure what that is, so we're going to skip that one. Transitive property, if one thing is equal to another thing and that thing is equal to something else, then that means the first thing and the third thing are both equal. That's not right here. Reflexive property states that whatever something is, it's equal to the same thing. So that would be if AB is congruent to AB, or if CD was congruent to CD, which is not shown here, although that would be true. Also, an example of the transitive property would be if AB is congruent to CD and CD is congruent to EF, then that means EF would be congruent to AB, which it doesn't show in here. So this one's actually a symmetric property, okay? Whenever you have something that's equal to something else, you flip it around, different order, still equal, symmetric. All right. Which postulate states that if B is between A and C, then AB plus BC equals AC? Okay, so let's just say you have A right here, and then you've got B in the middle, and then you've got C all the way on the end. So the distance from A to B, and then from B to C, equals the total distance from A to C. Is it the ruler postulate? No, don't forget the ruler postulate says that if you have something on 0, if you have one point of the segment on 0 and the other point is on a number, whatever that number is, that's how long the segment is. So this does not state that. Okay, so we're probably not going to say ruler postulate for this one. Segment addition postulate, you better believe it. Oh yeah, that's what it seems like to me. Addition property of congruence. No, that is not what it is. It would be that if it said AB equals AC, and then AB plus BC equals AC plus BC. But it doesn't say that. All right, so it's not addition property of congruent, and it's not whole segment postulate, which I'm not 100% sure what that is either. So it's got to be number B. Let's see what happens if you hit a hint. Oh, wow. Okay. Yep, that wasn't super helpful, but I guess, hey. Okay, so 3, 4, and 5 all kind of work off the same proof here. So what we're going to do is we're going to go through this. All right. So we've got here AC is congruent to DF. All right. Actually, for number 3, we're just supposed to find part F. So as you can see here, we've got substitution property. Okay. And then the last one can't be definition of addition, right? There's nothing there that would be to add. All right. Can't be definition of a line. No. Symmetric property. No, it's not going to be the symmetric property. It's going to be definition of congruent segments. Because as you can see here, the first thing we did was we moved these congruent segments, as you can see, into equal signs. Okay, and that's the definition of congruent segments. So we made it AC equals DF and BC equals EF. So it's actually going to be number 2 would be AC equals DF, BC equals EF. Let's see, did they ask us for number 2? No. Okay, so I don't care that much about number 2. They do ask us about C. Okay, so as you can see here, what we've done is we've done AC minus BC equals DF minus EF. So what we'll do here is we'll go down all the way to C when it asks us for C. All right, and that is actually going to be, as you can see, we are subtracting. So it's going to be the subtraction property of equality. Okay, by subtracting AC, since we know BC is equal to EF, if we subtract BC from one side, EF from another, we've got the same thing, right? Okay. All right, so we know number 5 already. Let's go back up to number 4 here, okay? And let's look at number 5. So we know that this one is AC equals DF and BC equals EF. We know that this one is a subtraction property. We know that this one is a segment addition postulate. And we know that because what happens here is we say we have the segment AC plus BC, okay? And we know that AC plus BC is going to equal AB, right? AC or AC minus BC. So the whole segment here minus this section of the segment is going to leave us this section. Okay, we know that from the segment addition postulate. We also know down below that if you have DF minus EF, so the whole segment minus this section of the segment is going to leave us this section, DE. Okay, we know that from the segment addition postulate. So we know that AC minus BC equals AB, right? And we know that DF minus EF equals DE, okay? So now what we can do is we can sub these in, okay? We know that AC minus BC equals DF minus EF, right? And it also equals AB. So we can sub in AB for that. We can also know that DE minus EF also equals DE, so we can sub that in. And that is our substitution, all right? So that is why number 5 is B on this case. AB equals DE. That would be the substitution property. You're taking this equation, all right, and you're subbing in AB for these two because it tells you AB equals them right down here. And you're subbing in DE for these two, okay? And that's how you get AB equals DE. All right. And I think that's all of them. So this is the end of the quiz. So let's go ahead and end this thing. All right, let's see how we did. Oh, 5 out of 5. It's almost like I teach the course. It's awesome. Love to see it. Okay, boom. Wow. Okay, so if you have any questions on this, all right, you're like, Mr. Selby, I'm very confused by this. Can you please explain it? Not a problem. This is very confusing. And I realize this is really hard to learn online. Like, geometry is not meant to be taught on the computer. So I understand if you're having trouble with it. Okay, I can't imagine learning it online. So you guys are truly, truly, truly gifted if you are completely understanding everything. Okay, but if you are not understanding this, please, please, please reach out to me. Message me on Schoology, email me, come to office hours. Okay, let's work through it. All right, please don't just give up. I hope everybody is staying happy, healthy, hydrated, and safe right now. If you need anything, please reach out, and hopefully I'll see you guys soon.